All right, good evening again, students. We are back at another session and we're going to try these questions. You have 10 minutes in which to do so, and then we'll go through them together. All right, guys? Okay, you may begin. We have one new person joining the class today. That would be Javon Arthurs. Mr. Arthur, are you able to hear me? Javon, are you hearing me? Can you respond by either raising your hand or saying something, please? All right. All right, so good evening, Mr. Authors. Now, we have these questions that we are actually going to spend 10 minutes to do. So I'm going to ask you to try them. So Mr. Authors, you're going to try these questions. You are able to do them. And within the next 10 minutes, we'll be going through them together. All right, is that clear? Raise your hand. All right. So continue working, guys. All right, guys. So let me see the answer those who finish at least question 1. Anybody finish question 1? Could you hold your hands up? Raise your hand if you are finished with question 1, students. Okay. Okay, Mr. Ogino. Anybody else is finished with question 1? Okay. All right. So most people should get question 1. All right. So for the benefit for those who have not yet done question 1, we're going to do question 1 together, and then I will allow you to do question 2 and see if you are on the right track. All right, now, if you look at question 1, what we notice about the denominator, students, is Waysome. What do we notice about the denominator?
Sir, all of them can be divided into 8.
Well, yes, true, but that's not exactly what I was looking for. Anybody else can say anything about the denominators?
They're equivalent, sir.
Not really that they're equivalent.
They're different, sir.
They're different. They're not the same. And the first rule of adding fractions says that only fractions with the same denominators can be added or subtracted. Everybody remember that? So in order to add fractions, their denominators are not the same. Now, if the denominators are not the same, what do we need to do in order to add them? Ms. Cummings?
Sir?
What do we need to do to add fractions where the denominators are not the same?
Sir, we will need to find the lowest common factor.
Is it the lowest common factor? Is that what you want to say? Can somebody else?
Multiple.
Okay, thanks, Fabia. So it's not the lowest common factor, but the lowest common multiple. There's a difference between factors and multiples, all right? Now, before I jump into this, I'm just going to ask Mr. Arthur to just introduce yourself a little bit, Mr. Arthur, so that everybody can know something about you. So could you just say why it is that you're doing math, whether or not you like it or dislike the subject? Go ahead, Mr. Arthur. Mr. Arthur, I'm not hearing you. Is your mic working, Mr. Arthur? Mr. Arthur's? Can you type something in the chat so that we can know whether or not you're hearing us? All right, in the meantime, so trivia, we say that we need to find the lowest common multiple. And in this case, what is the lowest common multiple?
8, sir.
8. And why 8 is the lowest common multiple again?
Sir, because all the denominator can be divided by 8 itself.
Say that again. Because all the denominators can do what?
All the denominators can be divided by 8.
All right, I don't think that's what you really want to say. What you really want to say is that all the denominators can go into 8 without a remainder. They can divide 8, not 8 can divide them. You follow what I'm saying, Mr. Trivia?
Can you repeat that for me, sir?
So what you should have said is that all the denominators can go into 8, or all the denominators can divide 8. Not all the
Yes, sir. Yes, sir.
can be divided by 8. You follow?
Yes, sir.
So if they can divide 8, it means that they can go into 8 without a remainder. If you say divided by 8, what you're saying is that 8 will divide all of them. And that's not true. Following, Ms. Trivia?
Yes, sir.
Right. So the LCM is the lowest number that all the denominators can go into. And in this case, 8, all the denominators can go into 8. So 8 will be our LCM. So having found the LCM, Ms. Trivia, so let us write these. So we have a half. Half, we have 3/4. Then we have 7/8. All right, now, so our LCM, what are we going to do? Ms. Trivia, can you walk me through this?
Okay, sir. We're going to our LCM will be 8. So we would draw the line and put the 8 at the bottom.
Okay. And then
Then we're going to say 2 into 8.
2 into 8 goes how many times?
4. And then the 4 times the 1 over the 2 would be 4 ones 4.
Okay, so we say 2 into 8, we get 4, and we take the 4 to times the numerator for that fraction. So we say
Yes, sir.
4 times 1 give you?
4.
Remember, times in the numerator by the 4. 4 times 1 give you 4, so we put the 4 down here.
Yes, sir.
All right, next.
4 into 8 goes 2 times.
Okay.
2 times 3.
I'm multiplying our numerator by 2.
Which gives us 6.
So we put 6 down here.
And we put back the addition sign. Then 8 into 8 goes 1 times. 1 times 7. 7. Which gives us a total of 24.
A total
No,
of,
wait. Wait, that's not correct. Hold on. 7 is 14 and 3, 17. What's 17?
Right. So 6 plus 4 equal to 10 plus 7.
17 over 8.
So
How
we
am I
have
getting?
17 over 8.
Right. So 8
Fraction is,
into
what kind of fraction is that, miss? What type of fraction is this? Miss Trivia?
I'm sorry, improper fraction.
Right. So generally in math, we don't leave our answer in improper fraction. We generally leave it as a mixed number or mixed fraction. So let us mix it now, Miss Sylvia.
So 8 into 8 goes 1. 8 into 17 goes 2 times.
All right. So what the 2 represent here?
A whole number.
So we have 2 whole numbers. Because what we're reading,
And then
we're saying, remember that the denominator of a fraction tells you the whole or the number of parts that the whole has been cut up into. And so if you can get 8 parts out of the numerator, then that would be 1 whole. If you can get 2 times 8, which is 16, out of the numerator, then that would give you 2 wholes. So we have 2, and then the remainder would be how much?
1
And so we put back the denominator.
over the 8.
Right. Now, what we're actually doing when we mix, when we convert improper to mix, is that we're writing the number as whole number mixed with fractional parts. So everybody should be good with that. All right, any question about this? What we're doing, is everybody on track with this? Everybody knows how to do this? Raise your hand if you understand exactly how to do this one, students. All right, now I'm just going to ask that you do question 2, and then we check it and verify. Let us see all the hands of those who have done question 2 already. All right, Miss Green has done it. So only Miss Green, Miss Waysome, anybody else? All right, so I'm just going to allow the others to take about 3 minutes to do question 2, and then we walk through the question 2. All right, guys, go ahead and do question 2 for me, please. All right, so I'm going to start off with question 2. Ms. Wasom, you want to walk me through this one?
Yes, sir. Sir, are you hearing me?
Yes, I'm hearing you.
All right. So first, we'd find the lowest common multiple.
So we have 1/8 plus
Be careful.
2/3 plus 3/5.
Be careful to the little boy.
What is our LCM? So,
120. You put in the knife something.
all right.
Are you hearing me, sir?
Yes, I'm hearing you. Now the question is, let me see the answer those who did get who got 120 for the LCM. Let me see all the hands.
What do you mean I kept some water on
Those
it?
who got it so far.
What do you mean I kept some water on it?
All right, let me see the answer those who found it difficult to find the LCM of 8, 3, and 5.
I did, sir.
Right?
So because it is just so far off, we just turn off by all necessary.
Okay. Now for the first question, you could easily look at the numbers in the denominator and decide which is LCM. Now, when we find the LCM that we call that we're finding the LCM by. Now, not all the time you are able to just look